Hello, hello. Am I audible? This is Professor S.K. Das from IIT Raulkela. Hello. Osaria ma'am, are you there? Hello. 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 Hello.
Hello,
Yes, yes. Now it's audible.
Santosh sir is speaking.
Yes, sir. This is Geekofia.
Sir, I am
Yes.
Devashish Nanda. ଆଉ ସାର୍ ଆଉ ଟିକେ କିଛି ସମୟ 5 to 7 minutes ୱେଟ୍ କରିବା 5 minutes।
Sure, sure.
4 ଜଣ ଆସିଛନ୍ତି ଜମାରୁ। Let us join some more people
Okay, okay.
if you don't mind, sir.
No, 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 no issue. I think many are
Okay.
joining through online.
Yes. So, ସାର୍ କାଲି ମୋତେ ସୁଚିସ୍ମିତା କହିଥିଲା
Mhm,
ଆପଣଙ୍କ ବିଷୟରେ।
mhm. So I'm just uploading the PPT. Just have a look. It is. Try,
Okay, sir.
So is it visible?
Yes, it is visible, sir.
Okay.
मैडम जॉइन करना सर जॉइन करो IoT स्मार्ट सिटी। सर
Yes.
नो नो ओके सर shall we start now?
Yes, yes. We'll start now.
Okay, students, shall we start now? I welcome Dr. Santosh Das from NIT Rourkela of Department of Electronics and Communication Engineering. He will deliver a lecture, a webinar on IoT applications. I think this is the most advanced technology right now and it is developing. So I'll request all of you to please attend mindfully and I'll request Dr. Das to take over now, sir.
Uh, Thank you, Dr. Nanda. Good morning, everyone. So I'm just going to my slides. Is it visible? Just have a look.
Morning, sir.
Yeah, good morning.
Yes, yes, sir. It is visible.
Okay. Okay. So I'll start my talk on IoT for smart city applications. So basically nowadays, people are very advanced. They like to follow the culture of new technology in a smarter way. So now everything you can see in your daily life, everything is in a smarter context. Whatever you can see, everything you can control from your fingertips. Everything you can control through website. Everything you can control through Android apps. So there are many things you can see which are controlled by the human beings personally or as a team. Everything can be controlled. So how those things are controlled? So that is the application of IoT in Internet of Things. So in today's discussion, it is not, you can say it's a discussion. Today's talk, I'll be giving the overview of IoT and the application of IoT for different context. And mostly I will emphasize on the application of IoT for smart city. Nowadays you can see, there is government already declared there are many cities are called smart city, like Bhubaneswar, Raulkela. In Odisha, these are the smart cities. Cuttack, these are the three smart cities in Odisha. And you can say why everyone is saying that this is a smart city. What is the meaning of smart city? So smart city in the sense that many things has been automated, many things has been digitized, and many things has been controlled by the software only. And suppose you want to have a dinner, or you want to uh, have your breakfast at home, but you are not able to prepare it. So you can order and you can get it from restaurants which are located in far distance. So that is also one of the application of IoT. And another example is, suppose at your home, suppose something happened, like suppose fire or some other kind of activity uh, which are suspicious, those things are happen, then automatically that kind of activity can be detected, and automatically the respective division or respective in charge of that section, like fire station or like police station or ambulance, everything will be called automatically to that location. That is called that is another application of smart city. So that I'll give I'll mention many case studies related to smart city. We'll go one by one. So these are the outlines. So I'm going to discuss on today. I'll give the brief overview of IoT and its architecture, block diagrams, and some part of development and case studies. And mostly, I will be highlighting few things which are benefiting to the students, mostly in laboratory or product development kind of things. Those are very important. So now comes to the first point, that is the most important, that is the keywords of this talk, like IoT, Internet of Things. So everyone might be knowing what is IoT. Okay, IoT means Internet of Things, through which you can connect any kind of things which are available in the earth through internet. So that is called Internet of Things. And also, it is not like only to connect to the things. It is also important to collect information of that things or to control that things. So that is most important. That's why it is also called intelligent system of networking. You can connect any kind of devices, any kind of things, and intelligently you'll be able to control those devices. Intelligently you'll be able to collect information of those devices for further analysis or analytics, that which can be used for your applications. Okay, like for example, suppose you want to go uh, some places like industrial area where the pollution is very high. Some cases what happen, people are bit allergic to pollution. If they go to those areas, their health will be an issue. So in order to avoid that kind of situation, they can see the pollution level of those locations, those industrial areas, uh, using mobile apps or something like that. If that pollution level is okay for him, then he can go, he can move. Otherwise, he will cancel his uh, travel to that location. That is called intelligently, finding the pollution level of the location and informing to the user, so that user can use it for his own benefits. Okay, so that kind of applications are there by the help of IoT. So you can see here what is Internet of Things, how the Internet of Things has been used by the people. Like you can see, it can be used for educational purposes, it can be used for transportation system, it can be used for energy harvesting, energy management, business, then many things related to earth, home, like nowadays people are talking about smart home, smart forest, many things are there. So those things you can connect through Internet of Things for better security, better analytics, better management systems. Okay. So now I already mentioned about the definition of IoT, like it connects things. You can say these are physical uh, things, physical items, or maybe you can say these are the virtual things, virtually available. The directly not those informations are not available, but virtually those informations are available. And basically, the basic objective is collection of information from the physical world through by using sensors, by using networking, and many other things are there. So in this picture, you can see how the physical world has been connected through networking, and how those informations are stored actually in a cloud server or local server or something like that. So those information can be used by the people. The basic principle of IoT. First of all, you know, if you connect to any that device should have a sensor. That sensor has some kind of application like measuring temperature, humidity, etc., etc. So, by after measuring any kind of activity, that will be converted to analog data to digital data like 1010 from digital data, and those information will be collected by the edge computing devices. Edge computing devices like everyone might be knowing about microcontroller that can be used as a edge devices, which connect to the sensor, which collect the data from by using the sensor, and it will do some kind of processing at the edge. Then after processing those data, again it will be transmitted those digital data to cloud through networking. So in at the middle position, you can see it's a networking devices through which you can connect to server or high-end server, whatever. So it will store in the server systems. So these are the features of IoT, Internet of Things. Like you can connect anytime, anywhere. You can connect devices at any place. You can connect things at any point of view. So these are the features of IoT. Now comes to how it works. How the Internet of Things works for real life. So basically, this IoT it includes different type of processing like communication and cooperations, addressability, identification of things which we are connecting. Then sensing means by using sensors. What type of devices? What type of activity you are sensing? So that is called sensing. Then actuation. Actuation is another. This is the process after sensing. It will just actuate. It will initiate some kind of activity. That means embedded system means you can say a microcontroller. That is an embedded platform which will have some kind of processors units that that will be connected to sensors. After collecting data, the processor will do some kind of process. Then it will transmit to the cloud. That is called embedded system. Then localization, user interfaces are also there. Like suppose you want to see the temperature of one city. The city will have a temperature sensor that will be connected to some kind of microcontroller. Then the microcontroller will be connected to the internet, and it will be sending frequently data to the server through internet. Then from your fingertip means by using your mobile app, you can see the temperature of that city. So that user and interface is also very important, so that user can see the information, user can use it. So in the right hand side picture, you can see there is like suppose you want to control the bulb. So that bulb will be connected to the microcontroller. Then the microcontroller will detect something, the status of the bulb, whether it is on or off. That is the status of bulb. And if it is off, you can switch on also. If it is on, you can switch off. That will be by the help of mobile. So using mobile, you can switch on, switch off your bulbs, fans, AC, fridges, every anything, whatever available in your house, everything you can control from your mobile. So these are the technologies related things like how IoT works. Initially, you need to have some kind of a device which will identify the devices, that is called RFID. Then after identification, you need to collect information, that will be by the help of sensor. Then after that, you need to have some kind of technology which will process those collected information, that is called smart technology. Then also, uh, because you cannot use the bigger size devices, so you need to have some kind of technology which will, through which you can uh, you will have nano devices, like mobile is one kind of smaller devices. So before mobile, people were using desktop, uh, computer or laptop, etc., etc. Those are bigger devices. Now people are using smaller devices. Okay, that is called nanotechnology. Uh, there are many things that they are related to nanotechnology, like small IC, small sensor. Many things are there. So those are not going to discuss. These are the timeline of IoT, how it has been tremendously increases timely from uh, 92 onwards. You can see the growth of IoT. Now almost everyone is using IoT technology. So it has been surveyed in 2020. 50.1 billion people are using IoTs. I mean, 50 was not people. 50.1 billion devices have been connected to Internet of Things. So this is the exponential growth of IoT. These are the technology related to the IoTs, like security, privacy, in future internet. Future internet you can see likely to 2G, 4G, 5G, 6G. Those are called internet technologies. Those are also very important. Then knowledge aggregation, standards. Now everywhere there is a standard, like how do you transmit data, how do you process data, what is the format of data, okay, what is the format of connecting internet. Every uh, type of application will have a standard. Then nano electronics, like just now I was talking about smaller devices by nanotechnology. Communication, that is related to again internet. Communication technology. Software is another technology through which we'll be able to connect devices. We'll be able to connect information, like using mobile app, web app. Many things are there. Then system integration also there. Suppose you want to connect, you want to connect thousands of devices. So how do you connect those thousands of devices? You need to have a system which will integrate all these devices. Suppose you want to measure temperature of Bhubaneswar, temperature of Raulkela, temperature of Bangalore, temperature of Bombay. All city you want to measure temperature. Everywhere the temperature sensor will be connected to cloud through microcontroller. So suppose there are n number of cities are there. So n number of devices might have deployed on those in those domains areas. Those devices again need to be integrated at a at one place to collect all the information and to process all the information and to access all the information by the user. Then sensor network also very important, because there are lots of sensors are available in the world. So measuring temperature, measuring humidity, measuring air pressure, measuring blood pressure, measuring water quality, measuring air quality. There are lots of sensors are available. So networking for sensors are also highly important. How people are doing networking, like connecting sensors to the microcontroller, connecting microcontroller to the internet. These are the technologies used for sensor networks. Then embedded system is also very important. Embedded system means you cannot use this the desktop, or you cannot use laptop for just to measure temperature of a particular location. Though, because if you use desktop or laptop, those will be very expensive. Laptop cost is 1 lakh. You cannot put everywhere one laptop, right, to measure something. Instead of that, you can put smaller nano devices like microcontroller in each place, each location. That will have just cost 3 4 thousand rupees. Okay, sorry. So then again, another thing is called cloud computing. Okay, so cloud computing is the you can say the heart of IoT. Okay, through which all kind of data will be received, will be processed, will be analyzed. Then it will be informed to the user. So cloud computing is very important. So which uh, is a very important uh, uh, point for which is for data analysis, which is close to server side. Then discovery services. This is another one, another technology through which you can discover. Like suppose you want to track your car. If someone is driving your has taken your car and driving somewhere, you want to track that car. So that kind of technology is also available. How to track this is called stack of IoT. Like OSI 7 layer, like physical layer, sorry, application layer, that, and then session layer. Okay, and then you can say network layer, sorry, transport layer, network layer, physical layer, data link layer. In IoT also, it has different layers. Layer means these are different modules, and each layer will have different functions and independent of each other, but they will pass information from one layer to another layer. Like application, analytic engine, application platform, database, network communication, that is for data transmission, appliance software, then appliance hardware. These are different layers for IoT technology. So these are when suppose someone is developing some hardware devices, someone is manufacturing some hardware devices along with software, he has to follow these layers. So how to connect hardware devices, where to develop software, how to connect internet. So every function will have a API address, uh, physical information API. Then every system will have a database connection. So he has to follow. They have to follow the stacks. These are the potential of IoT. Like why people are using IoT. So basically, IoT by the when you are using IoT means you are saving money, right? Like suppose uh, you want some kind of now you can see nowadays, like suppose you want to do the addition of 1,000 numbers. How do you do? You cannot manually, you cannot do. There will be a calculator. So by using calculator we can add the 1,000 numbers. That will be easy. Okay, so uh, that way, you know the IoT will help for saving money, and also for saving other factors like manpower, then efficiency of the systems. Like suppose manually whatever you are doing, that may not be so efficient, but if you handle it through software, that will be giving more efficiency, will be faster, safer also. Okay, safety also another issue when you are using IoT. Like suppose there is a blast furnace, someone cannot go there and measure the temperature of blast furnace, right? Because that temperature is very high. So how do you know the temperature of that blast furnace? So that in those that uh, blast furnace, some sensor will be there which will be which will be measuring the temperature, and from mobile you can see the temperature of that blast furnace. Okay, so that way you can see there are lots of applications of IoT through which you can save money, you can save wells, you can reduce the you can increase the efficiency of the systems, you can reduce the expenses of the systems. Like uh, nowadays, many things are automated. Many things are automated. So once you feed it, then everything will be automatically processed. So if you do all those things manually, then you need manpower. So that way expenditure will be more. Okay. So this is the figure I have mentioned how people are saving money in industry by using IoT. Now comes to challenges. Uh, Now comes to challenges. IoT challenges. What are the challenges? Challenges are enormous. There are various areas in IoT like system design, data management, device management, service management, and security. These are different. The five different possibilities of areas people are working and still working. So there is no end. People are still working because connecting uh, almost all the devices throughout the earth is very difficult. That's called device management is very difficult. Connecting the millions of devices, then collecting data from millions of devices, then managing those information is very challenging. That is called data management. Okay, and also security that is also very important. Is a challenge nowadays. You can see there are lots of fraud going on. Like someone can withdraw money from another's accounts through mobile, through OTP. Many things are there. Hackers are there. They can access your system. Like whatever I'm presenting, someone can hack my system. He can take my PPT. Okay, so those are called security. So many challenges are there. Still, people are working on it. Okay. Now, this is another one. Industry 4.0. People are talking about Industry 4.0. It is related to IoT. Actually, application of IoT. Okay. So before Industry 4.0, there was always there were manual operations. People were able to manage the industry and the machines by using humans, by using employees. That's why it has mentioned Industry 4.0, like 1G, 2G, 4G, 5G, something like that in communication. In industry also, there is a you can say here this is a revolution. First revolution, second revolution, third revolution, and fourth revolution. So fourth one is called cyber physical system. Whatever we are talking about IoT, that is called 4.0. Okay. Before everything was manual. This is also same thing, like whatever I mentioned. This is a revolution, first revolution, second, third, and fourth revolution. I'm just skipping this. And vision of Industry 4.0 is whatever I mentioned. The vision of IoT. You need to have information at your fingertips. You should have some kind of application which can control by your fingertips. Okay, and mostly to save money, to increase the efficiency, to reduce the expenses. Many things are there actually. That those are called vision of Industry 4.0. So this is already I already mentioned about this: increase productivity, increasing quality, reducing cost, increasing safety in conditions. This is one example in industrial automation, that is application of Industry 4.0, mostly industrial automation, that is Industry 4.0. So every industry will have a control room. From that control room, they try to control the plants. They try to control the instruments. So now, initially they were trying to control manually. They visited the instruments or plant physically and try to control those. Now those plants and instruments, everything is connected to the control room through sensors and networking, and they try to control everything through the by the help of software. That is industrial automation. These are some application of industrial automation. Just I mentioned. No need to. I'm just skipping. And if you talk about pros and cons of automation, you know, pros there are many. Like replaces hard physical works, and you will be away from hazardous environmental conditions. Production will be faster and very easy to check the quality through automation. And cons are initially, if you implement IoT, initially it will be a bit expensive, but later on it will be managed. Comes to disruption of IoT. Disruption means how people are using IoT for their benefits, for their saving money, for increase the efficiency. How people are using, you just everyone know Amazon. So now from Amazon you can buy anything. Okay, Amazon is having his own store, own shops. No, right? They try to manage. They try to contact all the shops, all the businessmen, everything. Suppose you are buying pen, so or you are buying laptop. So in backend they do some kind of process. They ask the business people to register in their website. And if I order laptop, that message will go to that businessman. Then they will send the laptops to me. So in spite of having their physical stores, they are doing their business. That is called disruptions, and they are getting huge profit out of that. Amazon. Then you can see you know Netflix. Netflix. They don't have cinemas, theaters. They don't have anything, but they are doing business. Netflix. Okay. Nowadays you can say Alibaba, Facebook, uh, Uber, or you can say other any taxi companies. They don't have their own taxi. They just connect people. They use use others taxi, but they are doing the business. That is called disruption. Architecture. I already mentioned about this. This is the layering structure of IoT, like data acquisition, greenfield, data aggregation, data analysis. So data analysis will be through cloud. Data aggregation will be after gateway. Then data acquisition, those are sensors connected to the devices, IoT devices or sensors. This is the block diagram. If you want to develop something, maybe any module, IoT module, you will have this kind of block diagram. You should have a sensor. You should have a microprocessor, a microcontroller or processor. You should have gateways to internet. Then there should have some kind of application development program like Android, iOS. Many things are there. So this is the overall picture of IoT, how the remote users, cloud stations, and local users are connected through internet. There are 9 steps. Suppose you want to build any kind of application related to IoT. Step one is you should have the concept. Suppose concept means example. For example, if you take how to measure a temperature, that's the concept, right? So how to measure a temperature? See, for temperature measurement, you need one sensor, you need one microcontroller, and you need some kind of analog to digital converter. Then you should have some kind of a reference point, like to measure the exact temperature. So those are called proof of concept. So those concepts you need to present in the form of block diagram. Just now I was showing the block diagram, right? So you have to show like a block diagram like this. That then that block diagram you have to convert to schematics. That will be uh, implementation for implementation. So like these are the block diagrams, right? Sensors, processors, gateways, applications. Every block will have some kind of hardware devices like sensor. Sensor is a hardware devices. How the sensor will be connected to processor? What are the components of sensors, and how would you connect to processors? Sensor might need power. Okay, many things are there. So those are called schematics. So if you know the schematics, you will be able to connect sensors and processor. If you know the schematics of processor, like in a gateway, suppose how do you connect to internet from your laptop? Laptop will have some kind of RJ45 connector, right? So that connector you can connect to LAN point, or maybe the laptop will have some kind of Wi-Fi interface. To Wi-Fi interface, you can connect to internet. So every system or devices will have some kind of schematics. So that is very important. So that schematics will be designed, will be tested practically, like in laboratory. When suppose you are doing, you are just checking some kind of flip flops, or you are just testing and the gates like AND gate, NOT gate, OR gate. How do you test? So you'll have a Vero board, you'll have some kind of PCB board, right? Then by using those boards, you need wires to connect from LED to power supply. You need to connect to switches. Okay, many things are there. You need to connect power supply, 5 volt. So that that is for testing purposes. So that before that you should have a schematics. So then you want to replace those Vero boards or PC boards, everything, whatever, and you need to convert to a product form. So you need to go for VLSI design. Okay, you need to convert to, you need to remove all the wired connections. So that the wire connection should be internally should be there. Like you can see here you can see there are many components. Actually, there are the square boxes. Those are components, and those one component is connected to another component through wires. Those are connected devices. Okay, like maybe one box will be transistor, another one will be AND gate, and maybe connected to some kind of IC. So that way you can connect. Okay, that is called schematics. The then the bill of material BOM. So it will calculate the about expenses of this the manufacturing of the schematics using this bill of materials. Then fifth one is prototype. So after manufacturing, you can see this kind of device. Okay, so that is assembling sensor and electronics. Then you have to write device driver. Device driver means how to read sensor data. That is called device driver. How to detect sensors. Then you need to have API. Okay. Then for cloud infrastructure, Then you need to have some kind of client integration, uh, like a desktop, tablet, mobile, etc. So these are the step 5 is prototype. Okay. Step 6 is field testing. After developing one product, you need to test in field for 3 to 6 months. If everything is fine, if there is no error, then you can go for beta version. That is for testing. Then after that, you can go for production version. Okay. So after production version, you can release the product. People will be able to buy and people will be able to use it. Okay. So these are the 9 different steps for developing IoT products. And potential wise, already I mentioned, we'll be able to connect anything, any devices. We'll be able to get imminent information. Uh, then many things are there. Actually, there are so many potentials. So these are called different sensors. Sensors are very important in IoT. Without sensor, you cannot connect to device. Okay, you can see here there are different types of sensors: position sensor, proximity sensor, velocity, motion, displacement sensors, temperature, humidity. So many sensors are there. Okay, I'm just giving those things. Then there are hardware protocols through which you can connect sensors to the microcontroller unit MCU, like inter-integrated circuits, UART, that is called Universal Asynchronous Receiver or Transmitter. That is very important in MCU, microcontroller unit. And also it is known as RS232, RJ45, many things here. Then RS485. Many connective devices are there. This is one of them, RS232. Another one is called general purpose input output, that is GPIO. These are the pin. So suppose for any microcontroller, you can see GPIO. Those inputs, GPIOs, many of the pins you can use as a inputs, like which can be connected to the sensors. Many of the pins are called used as outputs, which can be connected to other devices like internet or any other devices you can connect. So these are the three basic hardware protocols: I2C, UART, and GPIO. And protocols are related to communication is they also very important. You should know all this. When you develop something, you should know all these things. One is MQTT, as message queue telemetry transport, okay, through which you can connect to internet. Then COAP, this is called Constant Application Protocols, and basically it is a specialized web transfer protocol for use with constant nodes and constant networks in the Internet of Things. So one example is REST API. So whoever involved in Android app development, they might be knowing about what is REST API. So REST API means this is a kind of interface through which you can connect to database, through which you can connect the hardware devices. These are a kind of standards. Okay, like for example, uh, when you are using USB, USB has its own standards. You can connect to any systems. That's why it is called standards. Okay, so if companies will develop USB as per their own convenience, then if you buy one USB, you cannot connect to your systems. Okay, so USB has unique features. It has standards so that everyone can use it and everyone can use it to connect to the devices. Okay, so these are this is just a sensor interface layer, which is very important because in IoT, sensor is very important, and connecting sensor to the microcontroller device, that is also very important. So for that, you should know what are the layers of sensor interface layer, like fast sensors layers. Those will be connected to internet cloud through various connectivity protocols, GPIO, I2C, SPI, ADC, timer, etc. Okay, so these are the things. And also you should know about AWS, Amazon Web Service. AWS, everyone might be knowing. Uh, Using AWS, you can connect to the cloud. And also, uh, cloud infrastructure is very important for IoT because you need to have a database for any kind of data gathering, data processing, and data analysis. So these are the things in the cloud infrastructure: management, storage, security, applications, elasticity, multi-platform, and accessibility. And another very important point is internet connectivity. There are various technologies are available. You can connect the internet through Wi-Fi, through Bluetooth, through RJ45. Many things are there. So these are the overview. Depending on data rate can be high, data rate can be low. So depending on data rate, you can use one of the connectivity, like for low speed data, short range communication. You can use Wi-Fi, Zigbee, Bluetooth. For long range communication, you can use traditional cellular networks, 2G, 3G, 4G, 5G, whatever. And for medium range, you can connect Sigfox, LoRa, NB-IoT, LTE, etc. So these are the overview of network connectivity. Now another important point is data networking. Data networking is very important because in IoT means data transmission. How you are collecting data, how you are transmitting data to the cloud. So that's why data networking is very important. So how do you transmit data means it needs to have one device. That device should have a low cost, low power, low battery consumption, low processing capacity, low storage capacity, etc. And also that device should have a, low throughput, high packet loss, and frequency topology can be changed. So that way, these are the characteristics of IoT devices. Yeah. And in data networking, mostly there are three. It has three objectives. One is routing. How do you transmit data from one point to another point? Okay. Second is analysis, data analysis. What kind of data you received, and what is the meaning of that data? That is called data analysis. Data analytics, that is another one. Data analysis and data analytics is different. Data analytics means it's a prediction means future. Suppose today temperature is 25 degree. What will be the temperature of on tomorrow? That is a prediction. Data analytics. Okay. So these are called application of data networking, and there are different uh, rules for data networks, like managing nodes, controlling nodes. Okay, and then transmitting data, then controlling routers, switches. Many things are there actually. So I'm just not giving more. So these are for long range communication. These are the technology used for long range that IoT communication: LTE, EC, GSM, NB-IoT, 5G, now 6G coming, FSO, free space optics, then wireless, Sigfox, LoRa. LoRa is for middle, and FSO can go for long distance communication, free space optics. It will go in the form of light. So this is for a long distance communication. Another one is for indoor communication, that is called Wi-Fi, same like Wi-Fi. Wi-Fi is for short distance communication, but the Wi-Fi connectivity is through RF, but Wi-Fi communication is through light. Okay, these are called long, short range communication: RFID, Bluetooth, Zigbee, Wi-Fi. Okay, so these are called Li-Fi is optical wireless communications. Then also you should know what are the cloud services related to any kind of developmental activity like Amazon uh, is providing AWS IoT. Bluemix is provided by IBM. Azure is provided by Microsoft. Redix is provided by GE. Exosites is provided by Texas Instruments. Artix is by Samsung. EV dot EV dot is another cloud service. ThinkSpeak is another cloud service. Nowadays, students are using mostly ThinkSpeak because these are free services. They can connect any kind of sensors, microcontroller to the cloud through ThinkPix. So this one is free. So mostly students are using ThinkPix. Then Cisco, then Google Cloud, B.O.S.E, IoT. These are different kind of services by different companies, and these are different business version of cloud services. And related to people and processes, by the help of IoT, you can see there are different six different applications of people and processes. I think no need to worry about this. These are the application of IoT for the use of uh, humankind. Then application of IoT, as I mentioned, our theme is smart city. So these are different applications for IoT, like smart lighting, smart grid, smart home, smart parking, smart energy, smart tax, smart cars, smart health, smart city. So these are different application related to IoT. Now comes to the application of IoT for smart city, because our topic was smart city. So under smart city, there are so many applications. So I am just summarizing few. One is traffic controller. Other second one is accident detection. Then third one is traffic density management control. Then crime detection, pollution monitoring, emergency vehicle management, and there are many other applications like smart home. Then I can see smart uh, uh, street light management, then smart garbage management system. Many services are there, but I'll be giving some case studies. That's why I have just summarized few of them. Okay, just have a 1 2 minutes breaks. Hello, I'm just want 2 minutes break. Is it okay? Whatever I just covered till now.
Okay, sir. It's very much okay.
Okay, okay. So after 2 3 minutes, we'll start again.
Okay, sir. Take your break.
Yeah.
ଆରେ ସମସ୍ତେ କଣ ଲିଭ୍ କରିଗଲେଣି?
ସେମାନେ ବ୍ରେକ୍ ନେଇଗଲେଣି।
Hello everyone. We'll start once again.
Yes, sir.
Okay. Okay. So am I audible?
Yes, sir. Audible.
Yeah. Okay. Now I'm just giving the overall architecture of IoT for smart city. You can see in this architecture, actually it is designed by me. Uh, you can see how the sensors are connected to cloud. This is one unit. So this unit is used for accident detection, and for detecting accident, you need to have a different type of sensors like sound sensor, vibration, gyroscope, accelerometer. So those sensors will be connected to microcontroller, and microcontroller will have a transmitter receiver or antenna, I can say, through which you can transmit data to the cloud. So this is a symbol of cloud. This is one module. Then another module is called parking system. So this is also every parking slot will have a sensor, and if someone is going to park in a parking space, that that will be detected, and that will be automatically informed to the automatically updated in the cloud. That is one system. Another one is called smart home. So smart home means like, suppose you want to detect fire, uh, then that will have some kind of sensor connected, will be connected to microcontroller, and that also you can connect to the cloud. This is smart home. Then another one is called personal pollution management system. Pollution management system will have different sensor. Then another system is called traffic controller. Okay. So, and another one is called I can say uh, yeah, criminal activity detections. So these are the different modules or devices which can be connected, all can be connected to the cloud service. So the cloud system will also have a different type of component like, analytics, cloud database, data management systems, that and that will have a different kind of application like mobile app, web app, etc. And again, that cloud computing system will have different components like, gateway, IoT devices, networking devices. End users will have web applications, mobile applications. Many things are there. So for end user kind of applications, this is the overall architecture for smart city. Okay, this is not for all the applications, but for a few applications on smart city. Okay, this is the schematics of IoT when you are defining. Already, I have mentioned about this. So if you see how sensors can be connected to the microcontroller devices, uh, so microcontroller devices will have different type of connectivity. It might have Wi-Fi, it might have Li-Fi, or it might have LoRa, or it might have RJ45, or it might have any other type of communication technology. So in this picture, it is showing Wi-Fi connectivity only. Through Wi-Fi connectivity, you can connect to cloud by using MQTT or HTTP protocols. Okay, and this microcontroller unit also will have a driver, so that is called device driver software. That device driver software is normally you also can develop by using through which you can read some kind of data, you can process some kind of data which are received from sensors, and you can transmit to the cloud. But standard protocols also, there is the standard protocols for IoT for different layers, like this IoT layer also use uh, application software, IPS objects, and then OMA, LWM2M. These are different API software. Co-op, I mentioned about co-op. HTTP, everyone might be knowing about HTTP. This is application protocols. Then routing protocols, these are very standard protocols. IP version 4, IP version 6. Then LoWPAN. Then related to hardware devices, Wi-Fi, Ethernet is 802.15.4. Then these are different, layering protocols. And related to IoT hardware platform, everyone might be knowing about board. So this Arduino board is based on at Mega 328P microcontroller. It will have 14 digital pins and 6 analog pins, and it can be powered by USB externally by 9 volts. And the program, you can program this device by using Arduino IDE, which are free. Okay, but this Arduino board doesn't have internal Wi-Fi and Bluetooth connections. So if you want to make it IoT devices, you have to buy Wi-Fi and Bluetooth devices, and you can interface to the board. Then you have to do some kind of programming to make it a IoT devices. Okay. Now it is another one, Raspberry Pi. Everyone might be knowing about this one. This one is a higher version of Arduino, and it is like a small computer. It is having memory, it is having processor. You can see CPU. It is for into ARM Cortex board with 1.2 gigahertz. This one is having CPU. Also, this one is having GPU, that is by Broadcom Video Core IB. And also this one is having memory, that is 1 GB. And also this one is having different type of connectivity, Ethernet, then wireless like Wi-Fi connection, Bluetooth, and also other than RAM, it has own memory card, that is micro SD. It has 40 pin headers connected to these devices, and also it has a HDMI connectivity, and analog audio video jacks, uh, Ethernet ports, camera serial interface, display serial interface. So it is similar to like a desktop, whatever functionality you can see in the desktop. So this Raspberry Pi is having all this functionality, and mostly nowadays people are using my Raspberry Pi for laboratory purposes, and this cannot be used for industry because this is not as per the industry standards. This is not as per industrial scale. So for industry application, people use higher version of microcontroller like NVIDIA board, or another one is called Xilinx board. Those boards are used for industrial applications. For Arduino, Atmel, and Raspberry Pi, these are used for laboratory purposes only, because these are not so efficient. Like these are temperature sensitivity. Like if you put this Raspberry Pi for 30 days in outdoor environment, this device might spoil. Okay, So this cannot be used for industrial purposes. Okay. So it has issue on sustainability for the industrial applications. But for laboratory purposes, it's okay for indoor applications. So this is another one, another microcontroller board. Okay. So like that, there are different variety of microcontroller boards. This is by Cypress. Okay. You can see dual antenna is 8 MB plus 2 MB RAM, and all applications are there. Okay. So this is the table for comparison purposes only for different boards, different microcontroller boards. Uh, the name also mentioned. The hardware names are there, like ARM Cortex. What kind of microcontroller they are using? So that is the hardware devices, uh, like Intel ARM Cortex, then Kinetics, dual core ARM Cortex, and what are the kind of interface they are having, like Wi-Fi, Ethernet, Bluetooth, memory also it has been mentioned for all kind of boards. So depending on your requirement, you can choose one of the board. Like suppose you want low memory, low cost devices, you can use only this first one, maybe Marvelous Easy Connect board. That one is having only Wi-Fi. There is no Ethernet, no Bluetooth, but price will be less. Suppose you want to use higher version, like Qualcomm Dragon board. That one is a bit expensive. It is having 1 GB memory. Okay, so and it is also having Wi-Fi and Bluetooth connectivity. So like that, depending on your usability, you can use one of the boards. If it is laboratory purposes, you can use many of the microcontroller devices which are used for laboratory purposes. Suppose you want to use for industry applications, you should have ARM processor, or you should have NVIDIA board, or you should have a Xilinx board. Those are used for ARM processor. Those things are for here. These are different type of sensors. Physically, you can see how just see and feel, like light sensor, temperature sensors, everything. So all these sensors will have interface input and output connectivity. Okay. Then there are different technological challenges. I already mentioned about this. And then solutions of two challenges of IoT means people are doing research and also testing in field. The tremendous activities going on. People are working on it. Now comes to the case studies which already done at NIT Raulkela, and also it is initiated by one startup company. It's called E1 System Private Limited. Uh, it is actually I am one of the founder of this company, and three more founders. Another founder is from ISC Bangalore, Professor. He is a professor, and two PhD students are working. Also founder of this company, and this company is focusing on product development for smart city. So these are the different products they are working on. Now they are having the prototypes, and is ready to deploy and ready to commercialize. One is accident detection, so then crime detection, heart attack detection, automatic traffic controller, automatic vehicle call, FSO for outdoor, Li-Fi for indoor. So these are for data transmission only. I'm not going to discuss about these two things, but I will be mentioning about accident and crime. So you can see here, these are the case studies for different nature, healthcare, then industrial application, building, transportation, environmental, agriculture. Environmental means pollution. One is related to environmental. Then traffic control is related to transportation. Then the you can say heart attack or emergency vehicle call, that is related to healthcare. And one more thing, I just want to share with everyone that suppose you want to either if you want to interested if you are interested to develop laboratory module or industrial modules or products, then you have to have knowledge about all these things. Actually, for any kind of product development, it is not so easy a for for only one person. So you need the people of having different backgrounds. Okay, like for any kind of products, the product will have the front end, that is I can say app, mobile app, web app, everything, and also it will have a back end where it will do all kind of processing, that is back end work, and also it will have a middleware, like when you are using the devices, then device also need to do programming, that is a middleware. So for all kind of scenario, these are the requirements, like software related for high level language, like middleware, you need to have uh, Python programming. You should have knowledge of Python programming. Without Python, you cannot do. Then for backend, like database management, connecting cloud, sending information, that will be by Node.js. And for front end, there are many languages are there, like Angular, Node.js, Android. Then many other things are there, like Afraid, Node-RED, Ionic framework. Ionic framework is for both iPhone and Android, and Android is only for Android phones. Okay, so Ionic framework is used both for web, Android, and iPhone. Okay, then ThinkSpeak is already so the students are using this student version, free version. ThinkSpeak. UB also is another cloud. So these are the software related things you have to learn. And also, as IoT means nowadays people are using AI, artificial intelligence. People are using machine learning. People are using deep learning, neural networks. Many concepts are there actually. Those are used for data analytics. That means prediction of data for future prospectus view. For those kind of things, also the developer should have this kind of knowledge. Yellow, that is you only look once. This is one model. And the one is single shot detection, SSD. Another one is RCNN, region based convolutional neural networks. And the one is W. So out of these four different models, W is a commercial version. It is used by the company people, and this model is very expensive. One license might be have 10 lakh rupees for 1 year. So that is mostly used for data analytics, that is prediction of data. And other than that, yellow, SSD, RCNN, these are open sources. People, student can use or a developer can use it. And this yellow, SSD, RCNN, they have their own library. You can access libraries. You can use those libraries. Like when you do some kind of simulation using MATLAB programming. MATLAB is having libraries. Like suppose you are doing addition of two numbers, a plus b, there might be some library in MATLAB. So here also yellow, SSD, RCNN, they have their own libraries, uh, which are already tested. You don't have to write code once again. You just call their library and use it. Like for example, suppose you want some kind of face detection. Okay, suppose now in this talk, many students are already joined, and they are just listening. I just want to detect their face. I just want to know who are listening to me, who are sleeping, or who are just don't worry about the talk. I just want to know from face what people are doing when I am giving the talk. So this for this kind of activity, uh, SSD, LO, RCNN, they have their library already. People had done lots of research and they put it in the library form. You need just need library form means functions. You just need to access those functions and use it. Okay, like for detecting face, uh, first you have to take photos and suppose you have to take 100 photos. Out of 100, few maybe 50 photos you can set as a training set, and rest 50 photos for testing purposes. Automatically the library will be taking those photos and it will say whose photos are there. So that kind of facilities are there in yellow, SST and RCS. Out of these three, the most efficient one is SST one, single shot detections. These are the most of the libraries are available in SST. Okay, mostly industry people they are using SST. This is about programming model. Then and programming model, and this is related to uh, AI, because nowadays people are mostly talking about AI, artificial intelligence. Okay. Then again for related to hardware devices, the someone should have a knowledge on microcontroller like Arduino, Raspberry Pi, Node MCU, NVIDIA, ARM, Coral, etc. Also, they should have knowledge of on sensors, and also they should have knowledge on network devices like Wi-Fi, Zigbee, LoRa, GSM, GPRS, LAN, Li-Fi, episode, Bluetooth, etc. etc. And technology-wise, also people should learn on the machine learning or deep learning, big data, edge computing, fog computing, blockchain, computer networking. So these are different technologies. So in overall, you can say there are so many things someone has to learn, but it is very difficult. So someone should learn Python, someone should learn the hardware devices, someone should learn the programming models, or someone should learn machine learning or deep learning. So that way, e- everyone will have a contribution for any kind of product development. Only one person cannot develop a product. The product development means it is it is the contribution of many people, not by one people. Okay, so that way, that's why nowadays people are in start. There are so many startup companies. They are struggling actually only because of this. They don't have this kind of a background, because startup means like I am one of the founder of startup UN system, but I don't have all this the the technologies, proficiency. So I might be knowing only Python, but I don't know about anything about uh, uh, edge computing, or I don't have any idea about computer networking. But I am good in Python programming. Okay, but if I know only Python programming, then I cannot develop the product, right? So for developing a product, companies should have the employees with different backgrounds. Okay, they can use their knowledge and they can develop a product. These are the things people should learn for any kind of development, IoT development. Okay, now comes to the case studies. This is related to accident detection. You can see there was some accident occurred. Then after accident occurs, the devices it will send information related to accident about the locations, everything to the cloud server. Then after receiving cloud server, it will process the data. Then it will inform to the ambulance automatically. So this is one idea. We already developed this product. You can see the figure in the left hand side. These are the product already developed and already tested. Okay. So This is a block diagram. I just mentioned about accident detection. It will have a different type of sensors which are connected to the processor and connected to cloud and a server. So this is the block diagram of accident detection module, and you can see individually it has been mentioned sensor module, centralized processing module. Then after that, it will go to the database where it will create some kind of software that will notify to the users. These are related to hardware devices. You can see here Arduino board, then power supply, then different type of sensors are there. uh, Um, then GPS module also there. Okay, sound sensor, vibration sensor, gyroscope, GPS module. Then everything has been integrated in one module, and it has been tested. Okay, so these are the notification messages during testing. You can send messages about the accident, like accident location through GPRS. If you click on this, it will show the location where exactly the accident has been happened. So this is the Google locations. Okay. And other than messages, also same thing can be emailed that related to accident alert. It will send accident location, and if you click on that, you can go. You can it will just guide like Ola. Like suppose you call Ola, you can see Ola is coming to you near to you like that. It will display everything. Now comes to crime detection. Crime detection is related to camera and mostly intelligence. It will detect any kind of activity. If it is, uh, it has some kind of uh, danger. I mean, the analytics, like if a condition is not good, then it will send notification message to the users, like ambulance, police station, or family member, or something like that. These are the same kind of related to accident detection. It will have edge computing devices that will be connected to cameras. Then it will send to cloud. Then there will be some kind of processing units, and notification messages will be received by the users. Same kind of block diagram, but in this case, instead of sensors, they use cameras. You can see here there are so many components are there in criminal detection. There are the cloud service, edge computing device, then data set, then mobile apps. Many things are there. Different types of crimes you can uh, by using that you can say you can develop, like abuse, arrest, arson, assault, burglary, slash, uh, explosion, shoplifting, stealing, vandalism, and weapon detection. Okay. Now then robbery, fighting illegally for suppose example, at some point at some location, someone came to you and come to you and fight with you. He try to kill you with knife or something like that. If camera is available in that location, that will be detecting automatically. So someone so two people are fighting, and someone is supposed is trying to kill another person. Then immediately it will detect and it will inform the police. Police will come automatically. So that is the objective of uh, this crime detection module. So no need to call police. Automatically, police will come. Okay. So this can be used at any location at smart city, or maybe located at office, industry, or house, anywhere. If any kind of any such kind of activity happens, it will be recognized. Okay. So these are the different crime types we can see, like gun detections are there, fighting, then it's related to gun. So these are some data sets have been taken, and the most important is like similar like accident detection. It will be sending notification message to the whoever's registered or whoever having this device. The person in charge will be getting notification messages, uh, either messages through WhatsApp or normal message, or through email, or through some other cloud services applications. They will be getting the clips, video clips of the event. Suppose I'm fighting with someone, that video clip will be recorded and it will be sent to the person in charge automatically with some evidence. See, it has been sent. The video clip has been sent through Gmail. Now another one is heart attack detection. Nowadays, mostly elderly people they are having heart attack. For that also, we have one prototype based on pulse rate and shoes fall detections and something like that. It has been detected. Uh, there is some golden period, and there are some specifications related to heart attack. Those data has been collected from doctors, and it has been programmed. So automatically, if someone got get a heart attack, then if they have the device, then automatically the message will go to the ambulance call. Ambulance will be coming automatically to the person. Ambulance with doctor. Another one case study is called automatic traffic controller. Okay. So that one uh, it's like you might have seen traffic system. Mostly the signals are fixed timers. So instead of fixed timer, this one is having this one is having cameras at every corner, and it will detect. It will count all these vehicles surrounding them. Suppose you can see here how many lanes are: one, two, three, four, five, six, seven, 8 lanes are there. So lane wise, the camera will be counting the vehicles, and based on the density, it will give high priority, and it will put green signal to the highly density lanes. Then they can pass the vehicles. If here you can see only one vehicles are there, one bike is there. So uh, this person will not be getting the priority. Rather than this the right hand side, these people will be getting uh, facilities to cross the traffic signal. It is a density based traffic signal. And also other than that, because the cameras are there, they also will be detecting who are violating the traffic, and if criminal people are moving around or any kind of mob, so they will be detected by the cameras and recorded. That will be sent to the police station. These are just animations actually. I'm just checking how data are collected, how those are transmitted to the cloud, then processed. Then based on those density, there is a controller. Those controller will make on and off all the signals like that. This is the animation part. Now another module is called pollution monitoring system and alerting system. Basically, the objective of pollution monitoring and alerting system is just I had given example previously, like someone suppose someone is having health issues, he cannot go he cannot go to the locations where pollution level is very high. So that is called alerting system. So every location will have a pollution devices. They will collect the information from various sensors, and they will provide the AQI, that is called air quality index. Based on AQI, the health the parameters has been mapped, can be mapped, and based on that, someone can decide whether he should go to that location or not. So that is called alert systems. So this is also having similar kind of block diagram like accident and criminal. but here only it uses sensors other than camera, but controllers will be same, and other processor, other things are same. So these are the pollution, the database related, like you can see methane, carbon dioxide, dew point, humidity, PM 2.5. So all this information you'll be getting through the database. So this is just it is showing the data received by the cloud. So this is not for user. User only can see information through mobile apps. So this is for automatic vehicle call. So this automatic vehicle call, it is a part of accident detection as well as a part of criminal detections. Okay. So once the either accident or criminal the activity has been detected, those information will be integrated or messaged through vehicle calls automatically. The vehicle may be police, maybe ambulance, maybe something else. So so these are the things you can choose what kind of emergency you need, like hospital, fire, police, everything. So based on that, automatically the call will be routed, and then the user can see the all type of applications, location, then movement of police or ambulance, everything user can see here. See, and the patient detail also the user can see. Doctor also can see the patient details. Okay, and driver details, hospital details, everything it can see. And related to all these case studies, whatever I mentioned, there are lots of laboratory work can be done, like familiarization with Arduino, Raspberry Pi, and platform necessary software installation, interfacing with LED buzzer, with the microcontroller, and also you can make on and off LEDs, and there is connectivity to Wi-Fi, Li-Fi, Bluetooth, etc. through microcontroller. Many experiments can be done. Actually, I just mentioned around 15 experiments. There are many experiments can be done, like how to connect database, how to connect Bluetooth, how to measure temperature, humidity. Okay, so then how to display information in website. Okay, then many other data experiments you can do by using IoT labs. Okay, so these are can be used in IoT labs. These are few more experiments. Face detection using Pi, Raspberry Pi, then storing information in cloud, motion detection, speed control of motor. I think most of the lab they need to control motors, and and mostly nowadays the students are using robotics, right? Robotics means motor control. So this is just experiment how to control a motor that can be used for robotics. Then smarter door lock, pollution monitoring, and intimation using Raspberry Pi. So these are different experiments can be done. Whatever I presented. Future wise, IoT has a high uh, demands, and uh, nowadays, as I mentioned, the 50 billion machines has been connected, and in future, more than multiple of 50 billion machines can be connected. So it has no limit. It will go beyond the expectations. Conclusion: I mentioned about the definition of IoT, overview of IoT, applications of IoT. Then also I mentioned about the different protocols. Then block diagram of IoT. And then some summarization of product development, and technical knowledge to be involved in product development, etc. And also, I just mentioned about the few case studies related to IoT. So hopefully, this talk is useful for everyone, and you might be able to understand what I explain. And thank you everyone again. So if you have any questions, you can ask me or you can email me. So this is my email, the company email ID actually. Yes. And also you can email me at the our institute email ID that's SK. Also you can email me. And if you want to develop any kind of IoT lab, you can connect. So thank you very much. If you have any question, you can ask me. Already 120. The launch time is.
Sir,
Yes.
uh, everything is okay? Now you completed the seminar or
Yeah, yeah, it's completed. Yeah.
completed?
Yes.
Sir, you have a company registered in your name, isn't it? You are founder of a company.
Yes, yes.
So can you tell me actually what it is producing as a startup so that our student can better know?
Actually, the company is developing four products. One is on accident detection, other one is traffic controller, other one is pollution measurement, and other one is criminal activity detection. These are the four different modules, five different modules. We are developing products.
Okay, you are already it is in the market.
No, no, it's not in market. We are planning to commercialize. Now it is
Okay.
in development stage.
So it is a startup at Raurkela.
Raulkela, yes, NIT Raulkela.
Oh.
We also have office at Bhubaneswar.
You'll shift it to Startup Odisha Hub, O Hub.
No, no, actually, I have taken a rental. Actually, there is it's located at Tonkopani Road, Sai Mandiro.
Acha, acha.
Uh,
Sir, will there be any requirement of any employees right now?
yes, we need actually we need software developer and also we need a hardware developer for our company.
So can you have a campus interview with us at B.O.S.E Cuttack?
Sure, sure, I can go. Actually, we had a plan to go to your school because
So
we
that
need.
will be better. We are having a good number of students who
Yes,
are
yes,
interested to go in this line.
yes,
IoT, they have very much
yeah,
interest.
yes, yes. Okay, I will
Okay.
plan for that. So,
Uh,
yeah,
okay, sir. Thank you.
yeah.
I think all the students have benefited immensely from your talk about IoT in the smart cities.
Okay, thank you. Hopefully, yeah, it might had interesting.
Yes, yes. Because they are having a paper on that and we have a practical.
Yes,
Acha,
yes,
can you also NIT can guide us in setting up a IoT lab?
yes, yes. I can help. No, no issue.
Okay. Sir, what is the best amount is required or what are the products we need to um, add to
Yeah,
our lab?
yes, yes. I will ask one of our co-founder. I will ask him to email you all these things. Just
Oh,
give one email to me.
okay.
Then we'll mention about like today I mentioned about different the laboratory experiments. So
Acha.
like that, suppose I mentioned 24 experiments. What
Right.
are the equipments required? What are the software required? I will mention related to that.
Okay. Okay. Okay, students, do you have any questions regarding relating to the IoT topic which sir has delivered? So they can ask any
Yes,
question.
sir.
Please ask.
So first of all, good afternoon, sir.
Good afternoon.
Sir, what is the major difference between Raspberry Pi and Arduino board?
Only the Arduino board will not have any kind of network connectivity. Okay, and the processor also different. Raspberry Pi is having CPU and memory units.
Thank you, sir.
Yeah,
Any other student?
Good
Yes,
afternoon,
sir.
sir.
Good
Good
afternoon.
afternoon, sir.
Good afternoon.
Sir, how
Sir, my question is, what is the difference between IoT and industrial IoT?
Uh, uh, few microcontrollers can be used only for laboratory purposes, and many other microcontrollers they can be used for industrial application, like NVIDIA board. NVIDIA board is used for industrial applications, but Raspberry Pi can be used. It cannot be used for industrial application. That is only for laboratory purposes. So there is not much different actually by definition in IoT for industry. Okay. So it depends what kind of device you want to use. But definition wise same for normal application or industry applications. But
Thank you,
in
sir.
yeah, for industry application you need industrial scale sensors, like for humidity measurement, for temperature measurement. The sensors are available in market, might be 2 rupees or 5 rupees. Okay, but for industrial purposes, if you want to measure the blast furnace temperature, okay, for that case you cannot use that 2 rupees sensor, right? For that case you need to have another industrial scale sensor that might be having 40 rupees, 40,000 or 50,000 rupees cost. This is the difference, the industrial scale IoT or normal IoTs. Okay, normal IoTs only for laboratory purposes or prototype testing. For industrial means it's a product version.
Okay, anyone
Thank you,
else?
sir.
Okay,
yes, sir. Good afternoon, sir.
good afternoon.
Sir, how we use this IoT technology in farming purpose?
Oh, IoT for farming purposes.
Yes, sir.
Yes, yes, there are many things can be done in farming nowadays. In agricultural sector, people are using IoT only. So by the help of IoT, people are checking the quality of seeds. They are checking the uh, quality of leaflets. Then also they are automatically they are spraying medicines, and also they are detecting soil quality, and they are also detecting to uh, uh, provide water automatically. If there is no water in the soil, they can provide automatically. Okay, and also automatically you can control the water pump. So many applications are there in agriculture IoT related.
Thank you, sir.
Yes.
So I think there is no more questions from students, or is there any questions? Okay. Thank you, sir, very much for giving a wonderful delivery of IoT lecture on this topic, smart cities. Um, we will be looking forward further for any other type of webinar from you, sir.
Yes, yes, yes.
Thank you.
So I also thank you everyone to give me this opportunity to share my knowledge. Thank you so much. Thank you everyone. Have a good day.
Thank you,
Okay.
sir.
Yes.
Thank you.